one is vectors in 2D representation as well as in 3D representation. So before moving into that, let us recall the axis. In two-dimensional, we are having the axis x-axis and y-axis. And similarly, if it in case of z-axis, we will have an axis like this. It will be z-axis. So the right side is positive x-axis and the left side is negative x-axis, and here it will be negative y-axis obviously, and here it is negative z-axis. If an object in terms of vectors, this is known as origin. If an object is moving in positive x-axis direction, we will be representing that as a vector. Similarly, if it is moving in y-axis, we will represent that as j vector, and if it is moving in z-axis, it is represented as k vector. And the opposite to that side, I vector here, and here it is minus I vector, and in the y-axis it will be minus j vector, and on the z-axis it is minus k vector. So in the last class we have seen about last video we have seen about the unit vector. So unit vectors in the sense the vectors with magnitude 1, the vectors with magnitude 1, that is known as unit vector, which is represented by either a cap or whatever it may be. So in case of I vector and k vector, j vector, it can be represented as I cap, j cap and k cap. So what does it mean? So the complete direction is termed as I vector. In that one unit magnitude, this distance can be termed as I cap. And similarly in y-axis, this one unit distance can be represented as j cap, and in z-axis this one unit is represented as k cap, and in the negative axis it will be minus j cap, and here minus k cap, and here it is minus I cap. So in this direction, suppose if I am having a equation like 5 I cap plus 6j cap, which means in the I vector direction, I am having 5 units of I cap. So which means the multiplication of 5 cap, for example it is I cap, I 1 2 3 4 5. So in the direction of I axis I am having 5 units, and in case of y axis, it is represented by j vector. It will be having 6 units of j cap. So which means in the positive y axis, so it is 1 unit. So 1 2 3 4 5 6. So from here to here, the combination of these I vector as well as the j vector, it will be the somewhere position vector in x and y axis here. So I'm just drawing it roughly, you can understand it, because this z axis will be like it is coming out of your screen and it is going inside of your screen. Now we are just seeing about only one plane, that is having y axis and x axis. So it is somewhere a point. So this position can be 5 I cap plus 6 j cap, which has the orientation in I vector x axis, positive x axis, as well as in the orientation in positive y axis, which is j cap. So this unit vector, this is what a formula we have seen earlier, that if I am just considering it as I cap, it is known as I vector divided by modulus of I vector. Okay, so this unit vector, this I cap has no units. For example, let us consider a vector a vector, which is equal to 3I vector plus 4j vector. So I can find a cap by using the formula 3I vector plus 4j vector divided by modulus of 3I vector plus 4j vector. So how to find the modulus? It is simple. So whatever the coefficient of this I vector as well as the j vector, I have to, like, modulus of a vector will be the root of 3 square plus 4 square, which will be 9 plus 16 and it is 25, so obviously it is 5. So the a cap of this respective vector, that will be equal to 3i vector plus 4j vector divided by 5. So I can represent it as 3 by 5 I vector plus 4 by 5 I j vector. So this will be the a cap of this, that means the unit vector of the vector a. So it is the way we have to solve that unit vector. Now, so after this we have to know how we have to find the angle, and how we have to add or subtract the two vectors. So those were the things we are going to see. So the operations, like the arithmetic operations, especially the vector addition as well as the vector subtraction, we can do. So vector addition and vector subtraction, so to these rule we are having three rules. One is the polygon rule, and the first one, let us consider it, that will be the parallelogram law, and the second one it will be a triangular law, and third one it will be a polygon law. So parallelogram, whenever we are having two vectors to do the addition or subtraction, so these two laws will be used if we are having two vectors. Suppose we are having more than two vectors, we will be using this polygon law. So now let us see about that parallelogram law. So parallelogram law states that whenever there are two vectors, so let us have parallelogram law of vector addition. So if I am having two vectors that is acting simultaneously on an object, we will be making those two vectors as the adjacent sides of the parallelogram, and I will make that shape complete. After that, if I draw the diagonal of that parallelogram, that diagonal will be the resultant of these two vectors. That's what the parallelogram says, which means I'm just repeating again. Let us consider I am having two vectors. One will be the a vector and the other will be the b vector. So we are going to add these two vectors. Let us consider these two vectors are acting simultaneously on an object, and let us make these two vectors as the sides of the parallelogram. We are going to make it as a sides of the parallelogram. We know the parallelogram is a shape which is having the equal magnitude and the opposite sides will be parallel. So this side and that side will be parallel, and left side and right side will be parallel. So if I make these two vectors as an adjacent sides, that is very important. I am going to make these two vectors as the adjacent sides of the parallelogram, and if I complete the shape of the parallelogram, I will be getting diagonal, and that diagonal will be the resultant of adding these two vectors, which has been considered as the sides of the parallelogram. So now we are going to see about the derivation of this parallelogram rule. So the derivation, let us consider two vectors. One is a vector and the other is b vector. So here, to complete this shape, I am just extending the opposite side with respect to the same length of the below one. So here this length I am just completing the shape as like this. So as we see, so this so here what we are doing is, I just want to complete this parallelogram. So let me name this points as O, P, this will be Q, R. So we know that when this is B, I mean, let us consider this length as b. So this length will be also b. If it is a and here is also a. So to find, as I already told, that the diagonal of this parallelogram will be the resultant of the addition of the two vectors a vector and b vector. So in the next video we will continue the derivation of this parallelogram.